Welcome back to the channel. We are going to do a little bit of a fusion design. We're gonna design the scavenger drives. Now, keep in mind, I am really new at this. I'm learning myself, so if you know of some way of doing this a lot easier than the way I'm doing it, please share. So what we're gonna do is, first thing we're gonna do is we're in sketch mode. We're gonna create a 2-point rectangle. So we're gonna grab it like that, and we're gonna put in the dimensions 293 by 118. Okay. That is our the width and length of our plate. So the next step we're going to do is we're going to go ahead and click on a line right here. Click on this point down here, and we're going to create a line up here. So I know this top portion of the plate is 185. So we're going to try and find a close point in here, right about there, right? And then we're going to measure. I know there's probably an easier way of doing this. We're going to measure this. It's 61. We need to get it down to 54. So we need to remove 6, 7, or 4 millimeters, 6.3 something, right? So we're going to grab this point here. We're going to move it. Move this point, and we're going to go negative 6.4 or 3. And I'm just going to get in general vicinity now and see how much more I need to remove. 55, so I still need to move it about a millimeter. So let's do this. What was that? Move 1.335. Was it? 335. Negative. Enter. I know there's got to be an easier way of doing this. It's still overshot it by a smidge, so let's go move copy. This one 4. Probably if I used a calculator I wouldn't have to keep doing it, but I'm stubborn. Alright, 54 millimeters. So we're gonna have to do the same on this side. And like I said, there's probably some mirror function that I don't know about yet. Let's go there. 56,707, so we need to subtract 2,707. So right here, and we'll go in the other direction, so we don't have to do negative 2,707. .54 millimeters. So this center one now should be 185, I think. 185. So there's our plate dimension right here. So now we're going to put in our bolt holes. These holes need to be, for 3/16 bolt, they need to be 378 millimeters. Whoa, no. That's not right. That's way off. That's inches. Let me measure a bolt real quick. 9.3, so I would say 9.35 maybe? 9.35? 9.35. That looks about more. Uh, that looks a little more accurate. Now, so this needs to be this needs to be ½ inch from here to the bottom. So let's measure this point to this point. 12.631, so it needs to be, what is ½ inch? Is that 12? 12 millimeter, I think. Let's see. Nope. 12.7 millimeters. So, ooh, that is close. Man, I nailed that one, didn't I? So in order to get it where I want it to be, I need to move it up. So add 0.069 to this distance. So grab this, move this up 0.069. Okay, measure here to here, 12.7. So that is a ½ inch off. Now, like I said, there's an easier way of doing this, but I'm not the brightest tool in the toolbox, so I'm gonna do it the hard way. I'm gonna measure from here to here, 37, let me write that down, 137.754, and then measure same distance from here to here, 147.952. So let's do that. Let's do some math real quick. 147.952 minus 137. 137.754 equals 10 divided by 2 equals 50999. We have to go to the right 5 millimeters, 5.099 millimeters. So we move, select this option, and then we go this way 5.099. Okay, and now let's measure again from here to here, 147.491, and from here to here, 147.562. Why is that off? I mathed it wrong. So 147 and 147, 491, 491. And that probably 491, let's see, and 562. 562. Overshot it by a hair, I think. So let me see here. 562 minus 491 equals 71 divided by 0.562 minus 0.491 equals divided by 2 equals 355. So let me try moving it again. And this is probably something I need to learn, is how to move this stuff dead center, you know. Oops. Because I know I waste a lot of time just inching these things over. 147, 456. 147, 597. Okay, let's see. 456, 597. This way. A hair. Let's do this. Move. 476, 577. 0.5, almost. Five, 2, 6. 528. It's off by 0.1. So move. I know, people. There's an easier way, trust me. I'll learn it by next episode. 527. 527. Okay, that's dead center. Once again, I apologize. So now we need to put our holes. This is that center hole we have. We need to do a move copy, and this time we're going to do a copy, right? And we're going to go on this axis, since we know it needs to, all these bottom holes need to be a ½ inch from the bottom. We're going to just drag it, and we're going to put one here. Okay, and then we're going to do the same thing. Move copy, and put one here, roughly. Okay, I'm going to move them to the correct positions in a minute. Okay, so the one from this side has to be 44. One from this side has to be 44 millimeters from the edge of the plate. So we're going to get this, we're going to get this, and we're going to measure to here, 41. So we're going to subtract 1.825. So we're going to move this one, negative 1.825. Is that what I said? Okay. Then we'll measure it again from here to here. 40. No, it was 44 millimeters, so I need to go 4 millimeters the other direction. Move. This one. 4. Okay. So now, from here to here, 44 millimeters. So that one's in the right position now. Same thing with this one. So from here to here, 41. So I need to add 0.175 to 0.175, right? So move this one, and we'll do 2 0.175. Okay, and let's measure that from here to here. Oh, I fucked that up. Oh no, wait, I'm doing the inner circle. No, it's got to be the edge. 44 millimeters. Okay, so my holes are in the right position. Now, what we want to do is we want to make one of these holes elongated towards the edge of this, right? For that sliding one. So we're going to grab this one. We're going to do a move copy, hit copy, and we're going to drag it over like this. Hit OK. Now we have two holes. Now the distance between those holes was approximately I want to say 35 millimeters, right? So let's do this. Let's inspect this one to this edge. Nope, nope, nope. Okay, what did I do wrong there? Think of how I can get that measurement. Okay, I got a plan. They're 20 millimeters apart. Right, what did I say I needed them to be? I'm trying to focus here. Someone's pinging me. Hold on 1 second. All right, 20 millimeters apart, and the hole is 935, so 20 plus 935, 20 plus 9.35 equals 29 millimeters. And did I say I needed to be 35 millimeters? Yes, 35. So 29.35 millimeters minus 35 equals 5.65 millimeters to the right. So this one here move cancel, undo that. This one here, move to the right, 5.65. 5.65. Okay. Now theoretically, this should be the 35 millimeter length. So now what we're going to do is we're going to get our solid line. We're going to grab a line from this point to this point, right? And then another line from this point to this point, right? And then we're going to cut this one and this one, right? And then there's our oblong hole. Okay? Good. Perfect. All right, now we are missing the big center hole, which is 80 millimeters. So we need a hole in the center that's 80 millimeters. So let's do this. Let's grab this. $80. And then we're gonna move this right here for now. Okay. And then, like I said, there's probably way easier ways of doing this, but this is how I've figured it out so far. So now that we have this is for our motor, right? And then I know I have measured from the top here to this circle. About 13 millimeters. So we're gonna do this. We're gonna grab the measuring stick. We're gonna go here to here. Nope, not that. From here to here. 9.4, so we have to go down quite a bit. So 5. Point, see, 4.505. Yeah, 4.505. So we're gonna move this in the Y direction. 4. It's gonna be negative. Negative. 5. 505. Okay. Inspect from here to here. 14. Overshot it. So I got to come off 1. I am bad at math, so move this and let's just go up 1, right? Was it 1? All right. Okay, inspect from, oops, here to here, here, up, here to here, 13 millimeters. So that's right. Now we have to get its center here. So I think he might have had this one, Andrew might have had this one lower than these other ones, but I'm gonna check in a minute. But I know this because I measured this gap right here with my calipers and I got about 13 millimeters. So let's do from here to here, 119652. Where's my pen? 119.652, and from here to here, 120. 120.893. So I have to go over to the right a hair. So 893. Move it over 2 something. Let me see what the math is. 120.893. 893 minus 119.652 equals 1.24 divided by 2 equals 0.6205. So let's try move this one. 0.62. Oh, 0.62. Okay. And then let's just do a quick measurement. It's not going to be right the first time, but we'll. 163.26. 162.18. So I have to go a little more. 2183. So move it over by 5. Let me see. Let me dial it in a little bit closer. This one. Bump. Bump. 281. 264, 160, 264, and 281. 281, 6, so another 1 millimeter, 0.01 in the other direction, right? No, still in this direction. I know it's I know it's like fucking pulling teeth seeing me do this when there's got to be an easier way to find what center and move it center. 160, 271, 273. So 1, move it over by 1 maybe. The other direction. Move this. Minus 1. All right, let me take a measurement here to here, 272, and from here to here, 272. So we're dead center now. Okay, so we got that. Now, we have, what holes are we working on? There's 2 holes up here for our drives, right? So, basically what I'm gonna do is I'm going to take one of these right here and then do a move and then do a copy, right? And I'm just gonna do a free move so that way I can move it in the general area. Then we're gonna line it up. All right, that's about right here. Okay, and then we're gonna grab this one, and it's going to be 12 millimeters from the, or 13.7 millimeters from the top, which is a 1/2 inch. So let's get the measurement from here to here. 11.739. So this 11.739, so I have to move it down a hair. So actually 0.9, roughly 0.9 something. So let's do move copy this, and let's go in the y-axis, 0.9. Nope, the other way. Minus. Okay, measure from here to here, 12.6. So it was 12.7, so we need 6.061 down. Move this one, 0.61 minus. Okay. 12.7. All right, now that we have the location of that one, let's do this. Let's grab this one, and we're gonna do a move copy. All right, and we know it's gonna be on the same axis, so we're gonna slide it over here for now, because we have to get it in the right location. So, based off of my measurement on this inner circle here to this outer circle, it was 29 millimeters. So let's see, here to here, 23. Huh, close. So I need to move it away. So, wait, why didn't that, when I did that move copy, this one, why didn't it move it? Oh, I didn't hit OK. Never mind. What did I say I needed? Shit. From here to here, 23. 23.125. And what did I say it needed to be? 29. 29 minus 23.125 equals 5.87. So I got to move approximately 5.87. But what I notice is when you're doing a diagonal, it's not going to be, if you just do it with straight up math by moving it over, you're going to overshoot it, because it's just weird. Move copy this one. Now let's move it in the X by 5. What was it? 5.875. 875. And it's probably still not going to be there. 28. Yep, it's 28.189. So let's move it over another 8.8 or something like that. Let's do another 1. Let's just move it over 1. Move this 1. Okay. Inspect this to this. 29.063. Let's come back in a hair. So move copy this negative 3. Now, like I said, there's definitely an easier way of doing this. I just don't know yet. 3.7, so let's move it 3.7. Oh. 7. Okay. This to this. I'm back at 6.9. Move this. Negative. So 15. Let's move it again. Move. 1.5. Let's see what that does. I didn't do negative, did I? Wait, I'm going this way, so it was negative. Dialing this in is a pain in the ass, I swear. Negative. I'm at 2.5 again. Move copy. This one. 2, 5. Minus. Okay. It's off by 0.03. So 29 by 0.03, so I need to come in just a hair. Move. This one. Let's go 1. Negative. And you gotta know, because it's moving that way, it's also coming the way the dimensions are. It's just really, really weird. Because I'm measuring at a diagonal. Let's move another 2. Move copy this one. 2. Negative. Okay. Another 1. See, I moved exactly what it was, and it didn't go all the way, so. And now, this might overshoot it. We'll see. We'll see, we'll see, we'll see. That's it. So, as you can see, we're almost there for oops, what did I do? We're almost there for designing that one plate. And then what we're gonna do is we're just gonna copy this one plate, move it to the side. All these bottom holes to stay the same. We remove this circle in the center, put that diamond, and then we just add the bolts that hold the mount plate, which this one's gonna stay the same, which I need to measure and bring it down. You know, I'm sure I do. So I'm on the pan tool. So let me cancel that. And then let's move this one over, because I know it's got to get moved over from here to here. What is it? It is 20 millimeters, so I need to move it over approximately 9. Let's move it over 8. So we're going to grab that, move copy, select, and this one, 8. On the negative plane. Okay. Measure from here to here. 27. Need to move it over another 2. See how the dimensions don't translate exactly because it's on a measuring on a diagonal? Let's go 3. On a negative plane. 29, subtract about 5.5. 5. 2, let's subtract 2. Subtract 1. .22. And move this one. Okay. So there it is. So we have all of our holes in where they need to be. Now let's do this. Let's get it that shape we're used to seeing. We're going to snip that, snip that, snip that, snip that. And then now, let's add our bevels. So I'm going to grab a bevel, add a bevel there, bevel there. Now, we can adjust this to whatever radius we want. If we want a sharper radius, it's not, see, that's right there. That would be too much of a radius. Let's see, can we change that to 10? Right there. And then we're going to do the same thing to this side. And there we have it. Right? So at this point, if we wanted to, we can extrude our part, right? And tell we want the plate in, what was it, 0.125? Oh wait, no, that's in that's in inches, right? What is? Let me see. 3 millimeter, I think. I don't know. 3 millimeter. And we have our plate right there, all done. That's it. We've done one of the 5 plates for the Scavenger drives. Yay! All right, in part 2 of this episode, we're going to work on the other plate opposite of this one, and then we'll do the dog bones and the other parts. So there it is. I know this recording was pretty brutal because there's a lot I still need to learn myself about this, which I will. I plan on getting in there and learning. But I hope this helps you guys out, you scavenger designers out there or wannabe designers out there, so that way you guys can help out and make some cool stuff as well. So here it is. We've done plate 1 of the Scavenger drives. You guys have a wonderful day, and thank you for watching.